Hello everyone. Here is the video for section 3.1. Let me see if I can move that around a little. And this is going to be over section 3.1. We will do the PowerPoint today. You'll take some notes, and then next time you will have an assignment on this. I think that this might have to be in more than one video because this was only going to allow me to do 15 minutes max, and I'm still trying to figure out how to make this all work. Yes, there we go. So this particular section is about the measures of center of ungrouped data. There are 5 measures of center. Here they are: mean, median, mode, of course, and 2 that you probably are not as familiar with: trimmed mean and the weighted mean. Although I will tell you that many of you are very concerned about a weighted mean. We'll talk about that later. So first, let's talk about the mean. It is probably the most commonly used center or measure of center, and it has other names. Sometimes it's called the arithmetic mean, sometimes it's called the average. Yeah. So now we're going to have some different symbols that we use to represent the mean. So here's what it looks like. The mean for ungrouped data is obtained by dividing the sum of all values by the number of values in the data set. So we have 2 different kinds. We have the mean for population data. This is the Greek letter mu. It's kind of like a fancy little U with a tail on the front side of it. We have used the sigma notation before. So mu indicates that we are going to sum all of the data values together and divide it by capital N, which is the population size. And we have a mean for sample data, which uses this symbol, which is called X bar. So the X with the line over it, but is said X bar. And again, we'll add all of the data values together and divide it by N, which is the sample size. So here's an example. We'll have a table. It lists the total profits of 10 U.S. companies for the year 2014. Now, because we are only taking a sample of companies in the United States, 10 companies is way less than the total number of companies in the United States. We're actually going to be doing a sample mean here. So if we're using a sample mean, here's the information. The sample mean is going to be X bar. So we're going to add all of these together. Then we're going to divide it by the number of data values, which is 10. And we find out that X bar is 16,070.3 million. Okay. If you need to pause, obviously, at any time to write this down, please feel free. Then we have ages in years of all 8 employees of a small company. Here they are. Find the mean age of these employees. Since this is asking us to find the mean of all the employees, all would indicate that we're dealing with the population. So we're going to be using mu to calculate this one. So we add all of those ages together, divide it by the number of people there are, which is 8. We end up with 45.25 years. Okay, just some quick notes about mu and X bar. We can say that mu is constant since it uses all values in the population for the calculation. So obviously mu won't change for any reason if you're using all values. But X bar can change depending on which values of the population are included. So for instance, if I had just taken a sample of these employees, let's say the first 4, and tried to find the mean, and then I took the other 4 and tried to find the mean, I would get different values. Both of those would be X bar averages. Okay, so yeah. One major shortcoming of the mean is that it's very sensitive to outliers or extreme values. We talked about outliers in the last chapter, so we have to be really careful about using the mean. So here are the list prices of 8 homes randomly selected from all homes for sale in a city. Note that we have this one price of a home that's very different than all the rest of them. It would be included or called an outlier. So this says show how the inclusion of the outlier affects the mean. So you're going to have to do 2 separate samples here. Now again, because we selected 8 homes from all the homes, we're dealing a sample mean, which is going to be X bar. So the mean without the outlier, right? So we added up all of the other 7 values together, divide it by 7 is 315,000 and some change. If we include that really high-priced home, again, still this would be considered an X bar calculation. We're going to find out that now the mean price is 760,000 and some change. That's quite a big difference between what we got without the outlier. So you can see that sometimes the mean can be very, very sensitive to outliers depending on how far they are away from the other data. Okay. Next, we'll talk about the median. It's obviously the value that divides a data set that has been ranked in increasing order in 2 equal halves. So when we talk about a data set that's ranked, that means it's been put in order from least to greatest. I suppose it could be greatest to least, but generally least to greatest. And if the data set has an odd number of values, the median is the middle term in that ranked data set. If the data set has an even number of values, then it's given by the average of the 2 middle values. So you're going to see a couple of examples here in a minute. We're going to calculate the mean, you'll rank the given data set in increasing order, and then find the value that divides the ranked data set in 2 equal parts. This value gives the median. Now, I will tell you guys that I generally remember what a median is because when I think about driving down the road, sometimes in between the direction I'm going and the direction opposite me, there's this strip of land down in the road that is called a median. And I always think it's median because it's in the middle of the road. So that's kind of what we're talking about with this data point, is a median, something in the middle. So here is an example. We have a list of compensations of female CEOs of 11 American companies, and we want to find the median. Now this is an odd number of values, so we're going to be able to rank them, right? And then we'll find the one in the middle. So there they are. So rank the data in increasing order as follows. Here they are. There are 11 values, so the 6th value divides these 11 values into 2 equal parts. Hence, the 6th value gives the median as shown below. Here it is. Okay, so the median compensation for these female CEOs is $21 million. The following, here's another example. The following gives cell phone minutes used last month by 12 persons. So we're going to find the median of this data. Because it is an even number of values, we'll have to do a little extra work. So we're going to rank them, right, from least to greatest, increasing order. Now, we need to do a little bit of work here because now 1, 2, 3, 4, 5, 6, and 1, 2, 3, 4, 5, 6. So we know that our median is going to fall. It's going to be in between 326 and 380. And in fact, it'll be halfway between those two. And we do that by adding them, dividing by 2. And we find out the median is 353 minutes. A few other notes about the median. It gives the center of a histogram. So half of the data values are on the left, half of the data values are on the right. The advantage of the median is that it is not influenced by outliers. So if you notice on like this cell phone one, we had someone that was 160 and all of these kind of in the lower hundreds. And then we had, a couple really out here, but certainly this one that was almost 4,000. That would be an outlier, but it didn't actually end up making much of a difference in our median. And this is a preferred method or preferred measure of center for data sets that do contain outliers. So that's important. All right, so then we have this concept of resistant versus non-resistant. A summary measure that's resistant to outliers is called a resistant summary measure. Something that is not affected or is affected, by one or more outliers is called a non-resistant summary measure. So of course, based on what we know now about the mean and the median, it stands to reason that the median is resistant summary measure and the mean is a non-resistant. Okay, so resistant meaning it is not impacted by outliers. All right, next we have the mode. Yeah, and then I'll probably have to pause and you'll have to watch another video in a minute. So the mode is the value that occurs with the highest frequency in a data set. Where's the little cursor? There we go. So here we have a list of speeds in miles per hour of 8 cars that were stopped for speeding. Don't speed, people. It's not safe. And this says find the mode. So we're looking for the one that occurs most often. Hopefully you can look at that data set and tell that it is 74. It occurs twice. Everything else only occurs one time. But a major shortcoming of a mode is that it may have none or it may have more than one, where it will always have, a data set will always have one mean and one median. So we might call it unimodal if it has only one mode, bimodal if it has 2 modes, multimodal if it has more than 2 modes. So again, we'll just look at a few examples. Here is a data set with no mode. There are no incomes that are repeated in this list. So we just say no mode. Here's another one. We have their commuting times, people's commuting times from work. And so if we look at that list, we'll see that there are a couple that are repeated. 14 minutes would be one of them. And also looks like 23 is also repeated. Okay. And so you can see there is the answer. You've done mode before. Here's a data set with 3 modes. We only have 10 pieces of data and we have 3 modes. So that is also kind of interesting. We have 22, it looks like is repeated, 21 is repeated, and 19. And so of the 10, really 6 of those data values are in the mode. So that's kind of interesting. That makes it not very helpful to us. One advantage of the mode is it can be calculated for both kinds of data, both quantitative and qualitative, while mean and median can only be done for quantitative data. Right, so if we have 5 students who are members of the Student Senate, they're senior, sophomore, senior, junior, senior, and we find the mode, we know that we have 3 seniors, only 1 sophomore and 1 junior, therefore the mode is seniors. We can't calculate a median or a mean for this information. Okay, we're going to pause it there, and then when the next video starts up, we'll be talking about trimmed mean, which is kind of interesting.